Let's solve for the missing value of x. In the diagram, I have nested triangles. I have a smaller triangle with a base of x and a height of 5 that's inside of a bigger triangle with a base of 4 plus x and a height of 12. In order to solve for x, I'm going to set up a proportion because I have similar triangles in this problem. Similar triangles are triangles that have all the same angles. So here, both of these have a right angle. They share the bottom corner angle, and that leaves the remaining angle to be congruent. So the proportion we're going to set up is the base of the smaller triangle x is to the height of the smaller triangle 5. So we have x over 5, or x is to 5, as or equals the base of the bigger triangle 4 plus x is to the height 12, or over 12. Now, to solve this proportion, I'm going to go ahead and cross multiply. So I'm going to multiply x times 12, or 12x, and multiply 5 times 4 plus x. The quantity 4 plus x, so the 5 has to distribute. I have 12x equals 20 plus 5x. Subtracting 5x from both sides, I have 7x is equal to 20. And dividing both sides by 7, I have x equals 20 divided by 7. In this problem, we have a tank in the shape of a right circular cone that measures 12 feet high with a diameter of 10 feet is being filled with water. How many cubic feet of water are in the tank when the height of the water is half the height of the tank? Let's start by constructing a diagram. We need a tank that's shaped like a right circular cone that's 12 feet high with a diameter of 10 feet. So here is a sketch of my cone with a height of 12 feet, a diameter of 10 feet, and it's being filled with water. So we're being asked how many cubic feet of water are in the tank when the height of the water is half the height of the tank. Well, the height of the tank is 12 feet, so we want to know how much water is in the tank when the height of the water is 6 feet. We are interested in the volume because we want to know how many cubic feet of water, since volume is three-dimensional. Now, the volume of a right circular cone has the formula 1/3 pi, the radius squared, times the height. So we're looking at the volume of this cone of water here, and we have the height. The height is 6 feet, but what we're missing is we're missing the radius. So we're missing the radius of this cone of water here. So let's plug in our height of 6 feet, but we're missing the radius that we're going to need to square. Well, to find the radius, we're going to use similar triangles because I have this triangle here, the smaller one, with a height of 6 and a base of r. And then I have a bigger triangle here that is similar to it with a height of 12 and a base of 5 feet. So we're going to have to cut that diameter in half to think about the base of this triangle. So the similar triangle setup here is going to be 6 is to r. So the height of the smaller triangle to the base of the smaller triangle, r. 6 is to r. As the height of the taller triangle, which is 12, so as 12 is to 5. So that would be the base of the smaller triangle here. So that is the radius of the tank. And now we want to solve for r because we're going to need to plug that into our volume formula. So I'm going to go ahead and cross multiply here. I'm going to have 6 times 5 is 30, and 12 times r is 12r. I'll divide both sides by 12. So I have r is equal to, if I put this in lowest terms, they're both divisible by 6. So I have 5 halves. So r is equal to 5 halves. I'm going to substitute that back in over here for r. And the units of that r value are going to be in feet. The radius is in feet. So 5 halves feet. And then let's get multiplying here. So I'm going to leave this as pi over 3. I'm going to square 5 halves, which is 25 over 4. Square the numerator and denominator. I'm going to square feet, so feet squared, and then times that 6 feet. So now I can simplify the 6 divided by 3. That's going to give me a 2. I can also say, well, this 2 divides into 4 2 times. So what I'm left with is 25 pi over 2. So I have 25 pi in the numerator, 2 in the denominator, and then total I have feet cubed left over. And since this is a volume, we do want that cubic feet, feet cubed.